So let's look at a couple other examples dealing with standard form, a little bit more advanced examples. This first question says to write in vertex form the equation y equals x squared plus 2x plus 5. And a little bit later in this unit, we will talk about a process called completing the square. And completing the square is one way that we could write this from standard form to vertex form. But there are other ways that we can do it as well. So let's look at what vertex form is. And if you remember, vertex form is the equation y equals a x minus h squared plus k. Okay, so really what I need is I need the vertex, because I can see from this example, I know what my a value is, and I know that a is 1 here. So I already have that bit of information in my vertex form. What I'm missing is the actual vertex, the h and the k. Okay, so let's think about what we know about standard form. And we know in standard form we can find the vertex by finding the axis of symmetry. So the first thing I'm actually going to do is to find my axis of symmetry by taking the equation x equals negative b over 2a. So in our problem, that will be the opposite of 2 over 2 times 1. So my x is negative 1. And then to remember to find the y value to get my vertex, I would take and plug negative 1 back in. So we would get y equals negative 1 squared plus 2 times negative 1 plus 5. So y equals 1 minus 2 plus 5. So y equals negative 1 plus 5 is 4. So I know that my vertex is the ordered pair negative 1, 4. Well, now I can take this information and go plug it into my vertex form. So my vertex form is y equals a, which is 1, x minus the x value, which is negative 1, plus the y value. So we get y equals x plus 1 squared plus 4. So I've just taken my standard form and turned it into vertex form. If you were to look at these two on a graph, you would see that they are the exact same graph. Okay, let's try another example, a different type. All right, this one is going to be working backwards just a little bit. This one says to find a and b if the vertex is 2, negative 3, and the equation is y equals a x squared plus bx minus 27. Okay, so there's a couple things we need to consider. We know that this right here is the x value of my vertex, but this is also the axis of symmetry. Right? And if that's my axis of symmetry, I know that when x equals negative b over 2a, I get my axis of symmetry. So let's make a substitution. I know 2 equals the opposite of b over 2 times a. Okay, I can take this a step further. And if I multiply both sides by 2a, I would get 4a equals negative b. This is going to come in handy, so hang tight to this part. We're going to use that in just a minute. Actually, I may change it just a little bit. But what we also know is that when I plug in my ordered pair, when I plug in 2, negative 3 into an equation, it needs to make the equation true. Okay, so what does that look like? Well, let's do that in a different color. Let's say that y, which is negative 3, needs to equal a times 2 squared plus b times 2 minus 27. Let's simplify this just a little bit. So we get negative 3 equals 4a plus 2b minus 27. And it might make my life just a little bit easier to then add over the 27. and I get 24 equals 4a plus 2b. Now what you'll notice is I have a system of equations. Okay, I have two equations, both with two variables that I need to solve. Now my suggestion to you would be, let's rework this one just a little bit. Let's maybe divide both sides by -1 to get b equals -4a. Why do you think I might do that? Yeah, because now I can substitute this in. I can take this and substitute it in place for b. So let's do that. We would get 24 equals 4a plus 2 times b, and we know b is -4a. So 24 equals 4a minus 8a. So 24 equals -4a. Divide by -4, and we get a to be -6. Well, I've got one of my two variables, so a is -6. Well, now I can go back and plug this in to either one of my equations. It doesn't really matter which one. I think this one might be a little bit easier. So we would have -4 times -6 equals b. So b equals 24. So my a here is -6, and my b is positive 24. And that's just another example of ways we can manipulate the standard form equation to get it to be what we want it to be, and just different things we can do with it. So anyway, have a good day. We will talk to you soon.